This week we'll look at digital ethics. It's a pretty big topic, so we'll skim over quite a bit of it, but we'll pay particular attention to privacy and accessibility, because those are the hottest topics in digital ethics right now, at least for us. Okay, so what are we talking about when we're talking about digital ethics? Digital ethics is the field of study concerned with the way technology is shaping and will shape our political, social, and moral existence. Put another way, Rafael Capurro, in his 2009 paper Digital Ethics, said that digital ethics deals with the impact of digital information and communication technologies on our societies and the environment at large. This can be extremely broad. On the one hand, digital ethics covers what we might call meta-narrative topics, big ideas that we're trying to understand so that we can predict their impact, like the transference of consciousness to computers, or a world run by robots, that kind of thing. On another, digital ethics covers things like the impact of smartphones on our attention span. Is social media making people depressed? How do we eliminate cyberbullying? And then there are the business applications, which is what we'll focus on mostly because it's the most relevant to being able to do our jobs in our field. But let's start with the big stuff and work our way to the everyday application of digital ethics. The singularity. This is the idea that there will be a computer so intelligent that it won't need humans and will move into an age in which computers are in control. You can Google the singularity and ethics and find many academic papers written on the topic of artificial intelligence, or AI, whether the singularity would be a good or bad thing for humanity, and if we assume that it would be bad, what we can do to stop it from happening. One proposed solution is to program the AI's goal system to want what we want, basically to make it share our values. Another is to limit self-understanding in a computer system, so that it cannot improve itself, and therefore cannot become smarter than its engineers want it to be, like a limiting factor programmed in so that it cannot develop values of its own. Of course, many people think that objective decision-making will be a good thing, and for them, the idea of the singularity has the promise of a world order not corrupted by human weakness. We also have transhumanism, or the reality of cyborgism, whether it's machine augmentation like spectacles or prosthetics, or language chips embedded in our brains. There will be ongoing debate as to how to manage the ethics around technologically assisted humanness. Then we have robots. When we talk about robots, we often talk about the ethics of machines taking over human jobs. Of course, this is a complex economic issue as well as a digital ethics one. Some argue that automation in the workplace frees humans to do higher-level work that is more rewarding, easier on the body, and because it is more efficient, allows for a shorter work week, and thus more time for family and friends and what we like to call a life-work balance. But others argue that unless a framework for socially responsible automation is developed and enforced, technologies that were created to enrich our lives will have severe negative repercussions, such as an increased economic divide, as those unable to keep up with technology will be left behind and will be unable to provide for themselves and their families. And the potential for this extends beyond the individual or family to entire nations that could suffer economic collapse. These two people, in their paper Socially Responsible Automation, A Framework for Shaping the Future, from 2018, describe 4 levels of what they call the pyramid of progress. At level 0, we have automation that is only focused on cost, where technology is used solely to gain economic benefits by reducing human labor. This is the least ethical, or is non-ethical. In level 1, we have performance-driven automation, where processes and systems are re-engineered to take advantage of automation while still using human skills and abilities to fill technological shortfalls. So it's a combination of robots and humans working together. In level 2, we have worker-centered automation, where the business goals include worker development and enrichment. This system encourages new forms of human-machine interaction that actually augments human capabilities. And then level 3, socially responsible automation, where technology is employed to produce more and better jobs for humans, driving economic growth while also promoting societal well-being. For this, business leaders must commit to proactively identifying new revenue streams and job-enabling growth. Of course, there are other ethical issues that come up when we discuss artificial intelligence, not the least of which is at what point do we assign the rights to robots or computers by giving them status as sentient beings? And then that brings us to machine learning. If artificial intelligence is the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions, machine learning is a subset where algorithms improve automatically through experience, or where a device perceives its environment and takes actions that maximizes its chance of successfully achieving its goals. In machine learning, computers are trained on datasets to find patterns that can result in predictions. For the most part, this is a good thing. But Badadias or machine learning bias, in which an algorithm produces results that are systematically prejudiced due to erroneous assumptions in the machine learning process or errors in the training datasets, is a very real ethical problem. For example, using job hiring data from a firm with racist hiring policies may lead to a machine learning system duplicating the bias by scoring job applicants against similarity to previously successful applicants. This is a process of digitizing cultural prejudices. Machine learning is also very easily corruptible. For instance, in healthcare, where an algorithm could be designed to provide patients with unnecessary tests or medication in which the algorithm's proprietary owner holds a stake. We have to be very careful to understand that just because information comes from a computer does not mean that it's objective. Which brings up data privacy, which is a very large, very complicated topic that is on the forefront of any conversation about digital ethics these days. On the first day of class, you were asked to sign a FIPRA waiver, which explained that this course would use online tools and in some cases you would need to provide data, a username or email address to access those tools, which involved risks that your data would be collected and used outside of Canada. FIPPA, the Freedom of Information and Protection of Privacy Act, sets out the access and privacy rights on individuals only in relation to the public sector. It only affects how public institutions, like the college, collects, uses, and disseminates your data. The General Data Protection Regulation, or GDPR, on the other hand, protects all European Union citizens from any business or organization seeking to use their data. I've assigned a separate video about the GDPR because it's a great example of ethics around data and it has a huge impact on how everyone around the world is using the internet now. There are a lot of conversations these days about the fact that information about everything that you do on the internet, every site you visit, every link you click on is being recorded. This is called cookie profiling. Here's how Wikipedia defines a cookie. An HTTP cookie, also called web cookie, internet cookie, browser cookie, or simply cookie, is a small piece of data stored on the user's computer by the web browser while browsing a website. Cookies were designed to be a reliable mechanism for websites to remember stateful information, such as items added in the shopping cart, or to record the user's browsing activity, including clicking buttons, logging in, recording which pages were visited in the past. They can also be used to remember pieces of information that the user previously entered into form fields, like names, addresses, passwords, and payment card numbers. Cookies perform essential functions in the modern web. Perhaps most importantly, authentication cookies are the most common method used by web browsers to know whether the user is logged in or not, and which account they are logged in with. Without such a mechanism, the site would not know whether to send a page containing sensitive information or require the user to authenticate themselves by logging in. The security of an authentication cookie generally depends on the security of the issuing website and the user's web browser, and on whether the cookie data is encrypted. Security vulnerabilities may allow cookies data to be read by a hacker, used to gain access to user data, or used to gain access, with the user's credentials, to the website to which the cookie belongs. Tracking cookies, and especially third-party tracking cookies, are commonly used as ways to compile long-term records of individuals' browsing histories, a potential privacy concern that prompted the GDPR to require that all websites targeting European Union members gain informed consent from users before storing non-essential cookies on their device. This is why you get a cookie warning whenever you visit a website that uses cookies, and you can thank the GDPR for that, even though you aren't in the European Union. Next we have security, which is highly related to privacy, but it's a little more complex. On one hand, we have application layer security, like SSL and TCP, which we looked at last week. These add layers of protection whenever an application needs to send sensitive information from one device to another. The difference between HTTP and HTTPS looks something like this. This is called a protocol stack, and you can see that each layer starts with the Ethernet protocol and ends with an HTTP protocol, but that HTTPS has the extra SSL layer on top of TCP. Then we have security that protects your computer from malware and viruses, and internet security that protects your inbox from spam and phishing. And then we have security keys and blockchain. Blockchain is an extremely hot topic right now. I've assigned a reading on it this week because it's only going to become more common, so it's important that you understand it, or at least get the gist of it. If you want to know more about security keys, go back to the internet videos we watched last week on Khan Academy. At the bottom are a couple that explain security keys. I'm not going to assign it because I want to keep your workload down, but it's there if you want to increase your understanding of this topic. Next week, when we start looking at product development, we'll talk more about business ethics in relation to creating digital products, as well as the impact of cyberspace on the environment. For the rest of this week, we'll look at accessibility. Accessibility is about making digital products accessible to the widest range of people possible. We unconsciously create products for people with the same abilities and privileges that we have. This is different for each of us. Older designers, like me, tend to use larger fonts because our eyesight is typically poorer. People with fast internet connections, also like me, tend to include larger images and video files, things that load extremely slowly for people with slow internet connections. People with visual impairments that use screen readers are incredibly good at including the necessary markup in their HTML, things like alt tags to describe an image and proper semantic markup that includes information about the type of content included between the opening and closing tags of each HTML element, something you might not think about at all if you've never seen a screen reader. Following best practices for accessibility helps us move away from our biases and create products that everyone can enjoy in the same way. This makes the internet more egalitarian. It also helps us reach a wider audience. Search engines like Google score your website on its accessibility, and that score helps determine whether your website shows up on the SERP, or Search Engine Results page. This week's exercise involves studying the Accessibility Handbook provided by RGD, the Association of Registered Graphic Designers of Canada, and making an accessibility plan for our case study. Complying to accessibility standards will be a part of everything you make in this program, whether you're coding a website, designing a prototype, or coming up with a search engine optimization strategy. You cannot produce anything without taking it into account, so make sure you really understand what it is so that you can start to understand how to implement it into everything you make.